Hi, let's try and visit a case where we have velocity time plot and using the plot, how can we calculate displacement and distance covered by the object? And prior to that, let's understand the case of an object with uniform velocity so that it acts as a background to understand how we can read a plot as shown here. Okay, let's go ahead with the video. Uh, let's look at an object which is traveling with zero velocity, zero acceleration, which means it is moving with a constant velocity, but there is no acceleration, which is possible. So the acceleration is zero, but as you can see here, it's moving with a constant velocity. The velocity can be 5 meters per second, 8 or 10 meters per second. But at time t equals 0, it starts, and then till time equals t1, it travels. The velocity, let's say, is v1. We know that displacement is velocity multiplied by time. So when we multiply velocity v1 and t1 in this graph, v1 times t1 is nothing but the area of this rectangle. So the area of the rectangle gives us, in a velocity time plot, the area under the curve or the area under the line gives us the displacement. So this value of this area is displacement, and it is plus v1, so it is in the positive direction. If we consider this as an origin where the object starts moving, this is a positive direction for us, this is negative direction for us. Here the object has moved v1 times t1, whatever that value is, in the positive direction. And obviously for such an object, the displacement time chart will look like a line with a positive slope as shown here, because it gets displaced the same amount in equal intervals of time, and every second it gets displaced by the same amount. So this is the how the displacement time chart will look like. So with that background, let's try and study this plot. This is a plot of an object moving with a certain velocity at various time intervals, and that is what is shown here. So let's divide. How do we find out what is the displacement this object has undergone? How much distance it has traveled using this? Let's plot. Keep this as 5 meters per second, and this is minus 5 in the graph. This is 0. And we can divide this plot into 4 phases for study. Let's say this is phase 1, 2, this is 3, and this is 4. We know that if we calculate area under this curve, it is displacement. So let's look at it phase by phase. Phase 1, that is the line with this positive slope. What is actually happening here? And let's mark the time intervals here as 2 seconds, 4 seconds, 6 seconds, and 8 seconds. What actually happens till 2 seconds is the object is accelerating uniformly, which is why velocity is increasing constantly, steadily. The object is accelerating uniformly, and the time it does so is 2 seconds. So the area of this triangle will give the displacement for the first 2 seconds. So the area of the triangle we know is half times base into height, which is nothing but half times 2 multiplied by the height is plus 5, which is nothing but half into 2 into 5 is 5. So let's draw a straight line to understand this better. Let's say this is where the object starts, the origin. So now in phase 1, we know the area is 5. So it has got a displacement of 5 meters in this direction, in the positive direction. This is positive, negative for our reference. In phase 2, what happens? This is the displacement, this area, which is nothing but again 2 seconds, half times 2 is the base, height is 5. So it's again 5 meter per second, 5 meters in this direction. This is what happens in phase 2. So till here, the object has moved 10 meters in the positive direction. But in phase 1, if you notice, it is accelerating. In phase 2, it is decelerating, but still it moving in the positive direction. It moves from 0 to this point in an accelerating manner, and then from here to this point, let's say this is A and B. From A to B, it decelerates. What happens at D? What is the velocity at a B? velocity at B is 0. That means the object has accelerated till A, then from A it's applied brakes or decelerated and come to a velocity equal to 0 here. And then you can still see in phase 3 it is moving. There's a line here. What's happening here? It is still accelerating. The acceleration, it's uniform velocity, but in the other direction. The object is still accelerating, but in the other, that means it starts moving from with velocity in the other direction, in the negative direction. So this is what happens in phase 3. So the area of this triangle would be again half times 2 times minus 5, which means the answer is minus 5. So it gets displaced 5 meters in the opposite direction, or you can say the displacement is minus 5. Similarly, the last triangle here, it is 5 meters. It starts decelerating when it is moving in the negative direction. It starts decelerating from here till here and comes to a halt here. That is why at this point velocity is again 0. Comes to a halt there. And this is again 5 meters because half times 8 minus 6 is 2. Base half times 2 times height is minus 5. So minus 5 meters, which means 5 meters in the negative direction. This is what happens in phase 4 for this object. So let's calculate displacement now. Displacement we know is the sum of all these areas should give the total displacement from 0 to 8 seconds. So the displacement we have a 5 plus 5 and plus 5, phase 1 and 2, and then we have a minus 5 and a minus 5. So all this becomes 0. That means you can see here clearly in the straight line plot that the object has come back to the initial position. So though it has moved around so much, accelerated, decelerated, all that, the net displacement is 0. But there is definitely a distance covered by the object because it has moved around so much. What is the distance? How do you find it from the plot? For calculating the distance, we just need to take the magnitude of the areas without the sign. So this is plus 5, this is plus 5, this is minus 5, and this is minus 5. Ignore the signs and just add up all the magnitudes. It will be 5 plus 5. We add 4 5s, we get 20. Yeah, as you can see from this straight line plot, it is moved 5 meters plus 5, 10. Again, it has moved 5. So it has moved around 20 meters. The distance is 20 meters, but the displacement is 0. So this is how we can study a plot of a velocity versus time graph. Just remember always that the area under the curve gives displacement, and if it is a negative value, it's just in the other direction. If it's a positive value, it's in the positive direction. Whichever direction we take as positive, it is in that direction. So in this case, since the graph is symmetrical, by just looking at it also probably you can tell that the object has not displaced itself. Thank you.